Good afternoon, everybody. Yes, we strive for 100% circular packaging. And one important aspect of it is that we need to include more and more recycled content in the packaging. And in our group, we focus on sealing processes to be sure that the quality of the product is guaranteed. But what are the challenge when we talk about recycled content and when we talk about sealing? Well, when we talk about recycled content, when we look at the material, the characterization of the material, of the recycled material is different from the virgin material, even if we talk about the same plastics. And with post-consumer recycled, also the quality fluctuates from batch to batch. So there is no consistency between the material characterization. On top of that, if we focus now on sealing, well, for sealing depends highly on the material characterization, which means that we really need to understand which material we use to be able to understand and optimize the sealing processes. So the industry came to us asking, okay, I can increase the recycled content in my product, but what does that mean for my process? What should I do? How can I optimize it? And our answer to that is a predictive model. What is it? It's a tool that we can use to predict how the industry needs to optimize their processes, depending on the material, to guarantee that they have a good seal, that the packaging works properly for their product. So for that, we are building a model that can predict this sealing performance based on the material properties, the material of the packaging, and the process parameters. Currently, we are building a model for heat sealing, monolayers and monomaterial focusing on PE, so virgin LDPE, HDPE, or recycled PE, and blends of them. When I talk about sealing performance, what exactly does that mean? What are we looking at? Well, what we are doing currently is doing a lot of experiments to characterize that. So what we do is that we seal films together with heat sealing, meaning you have two hot bars that you press against the two films so they can melt the plastics and be sure that the two films are attached together. Now we let them cool and then we perform a T-peel. So we pull on it and we measure the force that is needed to separate them, to break the bond, so we can characterize how good the seal is. And that's what we have on the right. That gives us the force or the strength of the seal. When we have that, we can do that for different sealing temperature. And what we notice is that if we increase the temperature, the seal gets better up to a certain point where there is a plateau. So we have something that looks like that. And what we see is that for low temperature, there is no seal at all. The plastic is not melt. So the two films just stay separate. But as soon as we have this initial temperature, then there is some sealing occurring. And the higher the temperature, the better, up to a certain point where we damage the film because the temperature is too high. But what we are interested in is this area where we have this plateau, where we have this window of operation. And that's what we want to characterize, meaning we are interested in the strength. So what is the optimal, what is the maximum strength, what is how strong can be the seal, and at what temperature it actually starts. Of course, I talk about temperature, but as soon as we change the time of the sealing, that also changes. So the longer the sealing, the longer those two bars are against the film, the better it is. But of course, in industry, practically, we don't have the time to wait too long. So we want something that is optimized, that can be in high-speed production. So we want the minimum time possible to guarantee a good seal. So as soon as we include the time, then we have a different curve. And that's something that we are characterizing in our lab by doing measurement and experiment with different seals, with different film of different blends of PE. So when I talk about my model, then what we want to be able to predict is the sealing strength and this initial temperature when we know that there would be a good seal. Now, what about the inputs, right? I talk about material property and sealing processes parameter. What exactly does that mean? So I already mentioned a couple of things about processes. So the seal bar geometry itself has an importance, but also, like I mentioned before, the sealing temperature, the dwell time, so the time during which those two films are in contact and in between these hot bars, the sealing pressure and the cooling rate. All those parameters have an influence on the sealing strength. What about the material properties now? Well, to understand the material properties, we need to understand what's the mechanism occurring in the material itself when there is a sealing occurring. So here you see 4 images of the 4 stages where we see during a sealing process. So the initial state, what you see is 2 different films. In this case is multi-layer, so you have a print layer, a barrier, and a sealing layer. What we're interested in here is the sealing layer, where you see that already the surface is not flat, and you see inside the molecule, so the polymers that you have. If you start sealing them, you apply 2 hot bars on top and the bottom, you push on it, and your material starts melting and getting in contact one with another. Then what's happening inside material is that your molecule and plastic molecule are long chains, long molecule. They will start diffusing, and they will start going from the top to the bottom, from the bottom to the top, and mixed together. As soon as you cool down, then they will recrystallize and they will strengthen the bonds they have and the entanglement all those molecules have. So all these mechanisms are important to understand sealing processes. So when we want to model that, we want to understand that, what does that mean? What parameter are we looking at? So we need to know the melt temperature of the material. We need to know how is the surface. We need to know how fast the molecule can diffuse, and that depends on how big the molecule is and what is the structure. Just to give you an example, those are all PE molecules. You can imagine that this one might diffuse faster than that one. But at the end, if we look at the entanglement and the crystallization, that one can have a completely different entanglement than the top one. So all that needs to be characterized. And that's also what we can do in a lab, characterize all that, so we are also able to include that in our model. So here are a couple of parameters I mentioned, and you can imagine that if we talk about recycled content, recycled material, all those properties vary. They are different from virgin material again. So to give you the whole picture, that's what we want to build, a model that includes all of that. Well, how do we do that? How can we really include all those parameters? And our answer to that is using machine learning. With machine learning, we can look into all the different parameters I explained you to give us an answer on what is the optimal sealing process. What is the optimal sealing parameter? Practically, what does that mean? That means that currently we are building this model, and for that we are collecting data on virgin material, on recycled material for PE, with all the property I mentioned before. So we are performing all the measurement and all the data collection necessary for that, and we are feeding that to the algorithm, so the algorithm can learn and be trained to be able, in the future, to give prediction on totally new material that are blends or that are similar or slightly different material than what we trained the model for. So here you see everything we are busy with, from film making, extrusion, sealing, peeling, doing material characterization, and building the model. So we can answer the question, how can we optimize the sealing parameter depending on the new material we have? So like I said, we are currently focusing on heat sealing process, monolayer, monomaterial, and different PEs. But of course, we don't want to stop there. We are interested in other material, multi-layer, and other sealing processes. So if that's actually something you are working with, you are interested, please come to talk to me or my colleagues. Our booth is just there. We would love to talk to you about this and see how we can work together. Thank you.
Thank you, Veronique. Very enlightening. Are there any questions in the audience? Yes.
Yeah, so I got a question about the last sheet where you talk about looking at virgin plastics and recycled plastics. Are you also looking into, the one afterwards, I think, but are you also looking into different types of compostable materials that would be fully biodegradable or either compostable, one of the two?
Currently not, but that's clearly something we can look into.
All right, I'll stop by later then at the stand.
Perfect.
Any other questions? Actually, I have a question for you. First, a remark. It was good to see that you use pictures from colleagues in our field. So I saw your picture already in your slide, which is nice, so cooperation. I can guess before you can build a machine learning model, you need a lot of input. How much do you need and how do you get this input into your model?
For machine learning algorithm, we really need a lot. That's one thing. Currently, we are really building this database, so we're really performing all the measurements necessary because we have in our lab all the capabilities for that. But of course, that's also something that can come from industry, because every company gathers lots of data, and that's something we can actually help the industry with, is to really make sense of all the data they are gathering, learn from those data.
So that's a call to the industry as well?
Sure.
Okay. Okay. Tom, question?
Thank you, Veronique. Very interesting presentation. One question is, how do you see the industry is willing to share the data from the machine learning with you? Because they're always afraid that their competitors learn from these data as well. How do you see this?
Well, we don't really... the thing is that we train the model with those, but we don't really show those data. We don't... it's just to train the algorithm, but we don't share the data. So currently we had project with customer to build the model. So I guess it depends on the partner, but it's not incompatible.
And you can encrypt the data as well?
The data are not shown at all.
Yeah.
We use them ourselves to really train the model, but that's not something we use later on. As soon as the model is built and trained, then the model is there, and we don't show any data anymore.
Okay. Thanks, Veronique. Oh.
Thanks, Veronique. A few questions. You have any planning? How many years and etc.?
Oh, for what I showed, we hope to have something this year. That's the goal. Okay. Now, next year we will extend to probably multi-layer, but that also depends on partners and possible contribution. That's the idea.
Okay, thanks. You chose for the T-peel test, not for the hot seal test. Why did you choose the T-peel test?
The choice between T-peel or
hot seal.
Hot seal. Yeah, we started with both actually, but the heat sealing and T-peel was easier to characterize as a starting point. But as soon as we have something, I think hot seal could be really the next step. That is interesting to look into.
Yeah. Okay, thanks. And I think for companies, I mean, you get a new batch, you don't have any idea what the material will do, so you need some characterization, etc. You think it would make sense to have some simple tests that you start for the first I mean, machine learning means actually that you are sealing and you see what the seal is doing, but actually you want the right seal at the right moment, at the first moment actually.
Yeah.
So actually you need, in my opinion, you need some simple tests, or you could do with some simple tests, like melt flow index or whatever, and so on, and then start sealing. But it looks like that you have a curve of learning when you start with a new material.
Yeah, well, the thing is that currently we are characterizing our material in different direction because, well, from theory we know what influenced the sealing. Now we don't know exactly what is the importance of all these parameters. So we are looking into the couple I mentioned, but what we can learn from the algorithm is also which one are the most important, and then we can target the characterization that are needed.
Okay, thanks. Clear. Last question. We had a question from a customer. He wanted to seal a top seal on small bottles or between bottles and jars, and they absolutely didn't succeed. You are focusing on films. Are you also going to look at cups and top seals and stuff?
That's not the. Yeah, that could be. That's not what we are looking at the moment, and I think we will first extend into multi-layer, but that's clearly something that could be looked into.
Because then you have to combine characteristics of injection molding and blow molding together with film extrusion, and that's our casting, and that's rather different in characterization. Yeah.
Yeah, that's later on, I would say.
Yeah. Okay. Okay, thanks.
Thank you, Roland. Thanks, Veronique.